Okay, go.
Hey everyone, we're Team ClassCal. I'm Bill.
I'm Daniel.
I'm Wade. I'm Max.
And we're working on ClassCal Phase 2. Our coach is Professor Stumbo, and our sponsor is Jack Beck from the College of Art and Design. So we're going to go over our requirements and design and how that turned into our implementation, our process that we used to create our implementation, a retrospective on our work this semester, a slide about future work both for next semester and onward, and a demo of what we have so far. So the problem that Jack came to us with is that scheduling for upcoming semesters can be a real pain, especially in a department like film where there's a lot of specialized equipment. You might need a color correction room or an audio room. A lot of professors will say, I want this class at this time, and when you have a big Excel sheet full of the schedule, it's hard to see at a glance what's free and what's not. So what Jack wants is something where it shows a map of a building floor where the professor would ask where the room is. You pick a day, you pick a time, and you say, yes, it's free, no, it's not free. It's very simple. And it helps because a lot of times with complicated systems like Excel sheets, you might double book a room, you might double book a professor, you might schedule co-requisites at the same time, and the department wants to avoid that. So we were handed this project from a previous senior project team, and it does a very good job of meeting a lot of the requirements. It displays a map of Gannett and can show the schedule for a specific date and time. So you pick a date and time, you see a room, it's either green, available, or red, taken. When you click on the room, you can see what features it has. So maybe you want HDMI capacity of 30. It will tell you all of that, and you can make a decision whether or not you want to schedule it there. It has a calendar view, so you can see what rooms are taken, when a room is taken throughout a week, or when a professor is busy throughout the week. And you can make a reservation just by clicking on the room and saying what time you want, what days you want, when you want to start and end the reservation, and what class you have it for. So Jack wanted us to build off of this and add the Magic Spell Studios building. This is a new building that the College of Art and Design will be using for their classes, and we wanted to allow them to schedule for that because there are a lot of specialized rooms in there as well, and it's more of a complicated building than Gannett. And we talked about having a weekday time view instead of just a date view, so you can pick by semester and say what days of the week you're seeing a schedule for instead of just picking a specific date. We wanted to move from hosting on the SE domain to giving that ownership to the CAD so that they can fix it if something goes wrong. They don't have to go through us. They can change the deployment if they want. We want RIT authentication so that we can see when a professor logs in, they just give us the username and we see where they are in our system, what permissions they have, and base their permissions off of that. And at the beginning of the semester, RIT introduced new branding guidelines, and we need to update the app to adhere to that since this is an app within RIT. So with all of that in mind, we chose to refactor the front end. And why we did it is that while the original front end was great for the requirements given at the time, the new requirements aren't as great fitting with that front end, specifically with buildings. Jack has mentioned a couple times that not only does he want to add the Magic Spell Studios, but there may be more in the future, even with other sectors like hospitality, where he wants to add new buildings. And having Gannett coded into the system works really well for just Gannett, but if we want more buildings, we wanted a more adaptable way to show them. So not only do we allow people to add buildings into our backend so that they can display dynamically, we allow them to choose different shapes, so not just rectangles, but custom shapes based off of a set of coordinates. Also, restyling the UI is made much easier if you refactor, so that was another consideration that went into mind, but mostly it was about displaying the buildings. As you can see from a map of Gannett versus the Magic Spell Studios, there are a lot more weird shapes there, trapezoidal rooms that are on angles. If you go upstairs, there's a big entrepreneurial lab that's basically shaped like an L, and it's a lot harder to represent these shapes with simple rectangles. So we found it would be a lot easier if we introduced custom shapes and new logic to showing it off, whereas Gannett can easily be resembled by rectangles, and it has more of a old-style building construction.
Thanks, Billy. So, like Billy mentioned, we inherited a design and an implementation from the previous team that worked on this. So, after a round of requirement solicitation to try to understand Jack's needs and how those needs have changed since the original team made their design, we came to this new domain model that we verified against Jack to make sure it was exactly what he needed. You'll notice along the bottom there's a pretty simple and straightforward buildings, has floors, has room structure, and then each room has a room schedule which ends up being reservations of courses at times. Department chair and administrator are different roles in this diagram as well. That allows us to abstract the logic of who's able to access what away from what they're actually accessing. And we have this in our domain model, so we can talk about things like security directly with our sponsor. We made some changes to the system at the implementation level. We don't have time to go over all of those changes, but one of the bigger ones that we made was this here. On the left, you see the original design. Scheduled course is an entity that has some duplication in it. For example, if a course met 3 times a week in 3 different places, all of those records would have a reference to the instructor, different references. So on the right, we sort of normalized this a little bit. We replaced scheduled courses with all of these 4 entities, section being a little bit more semantic to academia, a little bit more maintainable in that sense, a little easier to talk about. Semesters were pulled out so that that's a little less repetitive again. So you can change the dates of a semester and you wouldn't have to worry about going through and updating all of the records. And reservations are also separate from sections here because reservations can exist in different places and you want to have those separated out. Not all the changes we made to the system were large. For example, here we just pulled out the idea of a department, so it wasn't baked into the idea of a course. That way, if something happens, like say CIAS would rename to CAD, we'd be able to update it in one place and have that reflected everywhere in the system. So after we went through and redesigned, we had to audit the system itself for implementation details. We decided that the React and Django REST stack that they had originally built the system with would totally meet our needs. The back end, we actually were able to reuse a lot of the existing models. With our updates, we estimated around 40% of the existing back-end code is still being used in our current implementation. And in the front end, they were making extensive use of React anti-patterns, like putting everything into state, if you've ever worked with React. So we decided it would be better to scrap that and build it from scratch. So in implementation details, the refactor included moving from Create React Apps built-in Webpack setup to our own custom Webpack setup. That gives us some easy things for free, like the ability to build SCSS, which enabled us to patch a Bulma front end to give us a look and feel that matches RIT's new branding. We also added Redux, so we have a global store that makes our front end state management a little bit easier to work with. And we combined the front end and back end code into a singular repository. That gives us a single source of truth for issues and for documentation, and gives us traceability from those issues to their implementation.
So we had to consider a few things when starting the process. One of the things was that we are the second team who are on this process. So we had to find the requirements document and other design to make sure that we can make a proper choice moving forward. And we also had a customer that was located at RIT, so it was very easy to get weekly meetings with him, which supported a more agile process than a plan-driven one. The process that we decided to go with was Kanban, and there's a few categories that we've used with each of the tasks. One was category, size, and priority. The category covered the area that it was in, so it was front end, back end, and infrastructure. Size would cover the size that it would take how long it would take to do the tasks. Designated by small, medium, large, and extra large. Small would take around a day, medium would take 2 to 3 days, large would take a week to half of a week, and extra large would be over 2 weeks. And if something's extra large, then we would usually break it down into smaller tasks. In priority, we have high, medium, and low to decide what sort of tasks we should be focusing on before others. In terms of metrics, we covered process metrics and usability metrics. We didn't start taking metrics as early as we would like, but for the process metrics, we covered the total number, size, and priority that are done each week. Number and size allow us to cover how much work was done in a given week to make sure that we were doing enough, and priority would make sure that we're focusing on the more important tasks, so that if we have a priority low for 1 week, then we want to make sure that we're not missing some higher priority ones that are hidden away. And we also cover the amount of tasks in each category to doing in review and completed. And the reason we did this was to make sure that one user wasn't doing too much at one time, and also make sure something doesn't stick in review for multiple weeks and is able to get through. Usability metrics were also important to us, since the main reason why this application was developed was to make scheduling the courses easier. And a few of the usability metrics that we wanted to cover was the time it took the user to complete a task, the amount of clicks it would take to complete a task, and the number of times they asked for help. This would help tell us if the user got lost when they were using an application, so that we would know to focus on that more and help reduce the task time by making certain features more visible. For testing, we covered one of the testings that we used for the backend was Postman, and the reason why we used this was because it was easy, because it had reliable, easy to use automated testing, and while we could also do it manually, and it helped document the endpoints, while at the same time it would be easy to transfer. It also makes it easy to transfer the testing into the code repositories. For the front end, we also used Husky and ESLint because it helped keep the pattern of help detect bad patterns in certain situations like unused imports and functions, so that we were able to keep the quality of our code higher. And we also did basic using tests using the back end using Django and the front end using Jest. Some of the risks that we perceived and some of the mitigation strategies is we were worried that the refactoring the front end would take up too much time, especially since some of our users were unfamiliar with the React framework and also didn't know anything about it or were shaky on it. So we made sure that we parallelized the front end and back end work, and we also made sure that the people that were familiar with the certain technologies were working on those technologies. So the person who's more familiar with React would be working on React. And also we were worried that the stakeholder might not like the new user interface that we're refactoring. So we made sure that we created some written designs so that the user would be able to look at it beforehand and also discuss the ideas with them, the implementation before them, so that we wouldn't spend time and resources developing it, and it's something that they might not like. And then for CAD, we also focused on CAD integration. Path was unclear, so we made sure we kept in contact with the CAD IT, and also we set it as a clear goal that we'd be focusing on next semester.
Yes, so kind of the retro portion and how we did this semester. So the good, we'll start off with that. We had really good team morale. We worked well together. It was always a positive, friendly environment during all of our meetings, including the sponsor meetings. We had code reviews for every PR, and we had early PRs as well. And all the PRs were reviewed by other devs, and incomplete PRs were created early so people could get an idea of what people are working on, increase the visibility. With the Kanban board, there's really good, again, visibility is a big part of that. We could see what others are working on and how far in the process they are with it. We had really good communication with CAD, which is important for deployment for next semester, so getting that early connection was crucial. And with that, we're also on top of our future tasks, and we've been communicating with CAD for SAML integration, and also we made a scalable architecture for not only next semester, but the future of this project if it continues to scale up. And we did a good job with readmes as well. So the bad, I have to talk about it. Kind of mentioned before, it took us a little bit to start with our metrics. We didn't start early enough. We started a little later than we wanted to, but going into next semester, we'll be able to kind of keep track in regards to our scope. And also, we went headfirst into coding a little bit early on, and we pushed some incomplete PRs that could have used a little more work, but as the semester went on, made sure PRs were of good quality, even if they were early. And also, not enough demos to our sponsor. Took a little longer to get to a point where we felt comfortable showing the sponsor where we were, but from now on and moving forward, we're in a comfortable state and can show off what we're doing much more often. So, the takeaways. Again, metrics. We are now on top of it, and we're going to be able to use that for the rest of next semester so we can really plan what we're doing appropriately. Focus on high quality code. especially towards the end of the semester, we really had to push for this and want to continue this into next semester. And also continue with the high code visibility, not only with the Kanban board of seeing what each other are working on, but the early PRs really help to not only see early issues that other developers might have with the current tasks they're working on, but it'll provide key visibility in what we're doing when integrating different parts.
So for future work, we wanted to, as before, we wanted to focus on the SAML integration with Shibboleth for RIT authentication, which was one of our main goals, and the authorization. We also wanted to focus on usability iteration, because with our sponsor, we talked about implementing keyboard shortcuts and testing more users to make sure that the usability is an improvement upon the old application. And we also wanted to add calendar views, which would be more useful, as in the current application looking at the room view, you can only see within certain times, while the calendar view will show all the times for a certain professor or room. And we also want to focus on the deployment on the CAD servers.
That was fun.
Yeah, we have a short demo to show to you guys. So I want you guys to imagine that you are Jack. You are using this system after putting in sections and courses, and all of that information exists. So we're looking for somewhere in this building to schedule a course for. So we're going to come to the application and choose a semester. Then we're going to choose a building to look in. Within that building, we're going to choose a floor. And then we're presented with a map of that floor. So this is the second floor of Gannett. We're going to select a day of the week. Here we're going to look at Tuesday, and the system defaults to 8 a.m. That's because that's the earliest their classes are. So this looks kind of full. We're going to look at 11, and oh, it's a little more full. So we're going to go back up to 8 a.m., and we're going to verify, yes, this favorite classroom of Jack's is in fact scheduled for this time. Then we're going to look at an available room, and we're going to choose to schedule it. So we select the section that already exists in the system of one of Jack's courses. We click Create, and that is reflected in the map immediately. That's it.
Questions?
So I'm curious about later on how buildings and rooms might be added. Is that something that a development team would be the ones for capable of, or do you envision that there would be a more user-friendly way to add those in terms of choosing, oh, this is what the map looks like?
So the goal was to make it so that you don't have to be a developer to do it. We made REST endpoints so that you can add buildings and rooms. Obviously, those are a little harder to use by the average user, but the CAD has an IT department, and we believe that we can onboard them with that. We have the Postman collection, so we already have fields filled in. So all you have to do is pick, I want to add a building, it has all the fields ready. You can just say, I want this, post it, and the building will show up in the system. Later down the road, probably past when we're done with this, it's very possible for people to be able to add buildings themselves, which is what we're going for by having the custom buildings, but it's not within the scope of our project for the next semester.
We also have some generic utilities on the front end that would make it very easy to make, like, so, fetch this resource, display a table of it, give me an option to edit it. We have forms and modals and things like that, that we already have a flow for that, for editing what instructors are in the system. So if we need to prioritize that, if that's the feature that the sponsor wants, we have a path to it.
So you said you redesigned the front end and didn't use any of the previous code. Did you research any other technologies besides React to do this implementation in, or did you just decide React code was done, let's keep it there?
We just chose React mostly on the basis that we already knew it and that it seemed to fit the implementation pretty well. And with the fact that we're refactoring, we don't want to add learning a new technology on top of that to create all that complexity. And that's the same reason we went with Redux as well. That wasn't in the original app, but it's because at least I was familiar with it. I think a couple of people were loosely familiar with it. We were thinking maybe going with GraphQL, but we thought that the learning curve for that and changing the backend for that would be awful. So a lot of this was about getting the refactor back up to speed with the old code, and that React seems to fit the implementation pretty well.
So the back end, you're able to keep some of it, front end, not much. How was the documentation side of things? Was there enough? Was it lacking?
In terms of technical documentation, there wasn't much. In terms of requirements elicitation and product description, there was a lot to go through.
Any questions? No, let's thank the team.
All right, hello. So we are working on Athletic, the coolest sports league management platform here in New York State, and we are Team Sports Guys. We're all guys here, and some of us here even watch and play sports. So without further ado, into the presentation. So introducing the team, I'm Owen Dong, team coordinator. This is Brian Jacobs, the team's scrum master, product owner, and resident sport/jock. This is Dan Fisher, our lead UI designer, and this is Ryan Hartzell, our lead security engineer. The other two members of the team that aren't up here but are in the crowd, Sean Bengry, our project sponsor, who has been fantastic and have been very helpful to us in taking this project off the road and making good progress. Professor Martinez, who has been very helpful and instrumental in guiding us through the project. Now, without any further ado, let's move on to the topics that we'll be talking about during this presentation. So, quick overview of what we'll be covering during this presentation. First, we'll talk about Athletic, what it is. I know I alluded that it was a league management platform, but there's a little more to it than that. We'll talk about the technologies and the implementation plan of the project that we've taken, the process that we've chosen to follow, as well as how we've handled the requirement stage, the design stage, and testing for our project. Afterwards, we'll move on to discuss some of the concerns and challenges and risks that we faced in this project and our mitigation strategies, as well as how we've planned to move ahead. Afterwards, we'll conclude with a quick status of our current project, as well as our future plans for the future. And without further ado, I will hand off to Brian, who will talk about what Athletic is.
All right, thanks. Yes, all right. So Athletic is our sports management platform. It's being primarily used right now for high school sports here in New York. It's used to manage a variety of aspects of sports leagues, such as sports seasons, games, team information, rosters, player stats, a bunch of stuff. It's a full solution system for what these leagues need. Currently, some of the problems that it has is it's very difficult to onboard new sports. With a new sport comes a lot of sports-specific requirements, and Sean, wanting to grow his business, wants to add as many new sports as possible, and that's very hard for him because there's a lot of software requirements that need to be added. So what our goal was, we wanted to improve the design and rebuild the system using new technologies and make a generic enough system that you can just click a couple buttons and then boom, all your new sports are in the system and your new league has all the requirements it already needs. Implementing all the current existing functionality of the system, we want to make the new system more extendable for any new requirements that a sport might have, because one of the hardest things to do is onboard a new sport with all of its new rules and new requirements. And we also want to focus on the maintainability of the system. This system started 10 years ago. Hopefully it'll be here 10 years after we're gone. So we want to make sure that we do our part and we hand it back off to Sean in a wonderful state. And lastly, we wanted to add our own strengths to the system. We wanted to design a lasting architecture using our knowledge so that Sean has the framework for any future features he wants to add that we couldn't get to. We also want to improve the security of the system and increase the usability and the user experience. I'm going to pass it over to Dan now. I'm going to talk about our technologies.
All right, so Legacy Athletic, as was said, was started development 10 years ago. And that means it was built using Adobe Cold Fusion and SQL Server. And so this system is in definite need of modernization. So when thinking about an implementation, we wanted to choose a technology that was easy to learn. Since our sponsor, we would have to hand it off to him and he'd have to maintain it and add features to it in the future. Another big one, obviously, is maintenance. So we want to make sure that there's a product that enforces design patterns on our system so that it's going to be rock solid in the future when we go to add additional features. Cold Fusion and SQL Server is more of a view on top of tables than an actual web application and interactable experience. And so to bring that into the up-to-date modern system, we wanted to add a web application to this. So we want to actually ship a real web application to Athletic. For that web app, we chose React, which a lot of you did here too. It's a JavaScript front-end framework developed by Facebook. And the only considerations we really chose for competitors were looking at Angular 6 or whatever the brand new one is. And there were some reasons we decided not to use that, mainly because our sponsor would have to learn TypeScript. Our sponsor would have to deal with a rapidly changing and evolving platform such as Angular, whereas React has stayed relatively stable over the years. And our web app is going to interact with the server through API endpoints and REST endpoints. And so we wanted to choose a server that was going to be really solid as well. We ended up going with Spring, which is a long-lived Java-based multi-purpose server platform. And there were really only a couple other options for this as well. Ruby on Rails was one we looked at. Node.js was something we looked at. But we really wanted something that would be enforced typing and really have strong maintainability. So if we went something like Ruby or Node.js, the typing really wouldn't be there, and our backend wouldn't be as strong as we wanted it to be. Finally, we chose MySQL Server as our database component for this new project, just because it's nothing fancy. It's not complicated. It has good performance needs for what we really want, and it's open source, so there's no extra cost to Sean like there is with SQL Server. And so, as far as technologies that we're working on otherwise, we're lucky enough that our sponsor has provided us with Atlassian Suite for our development purposes. So having the modern development tools has really been helpful for our team to move rapidly and implement new features as quickly as we can. For our code management, we're using Bitbucket, we have feature development and master branches like a lot of you. In addition, we have dev and prod servers that correspond to the development and master branches and in Bitbucket. And with that, we take advantage of Bitbucket's pipelines process for continuous deployment and continuous integration testing, which has really helped keep our DevOps cost low. So for process and story tracking, we're using Jira, which allows us to use powerful tools to help save us time. Something like doing story point estimation, doing epic planning, and doing sprint reporting with Velocity and all the other stuff you get with Jira. For our inter-team communication, obviously, we're using Slack, and our coach or sponsor are also on Slack, which really helps everybody stay in the loop. On top of that, we also have a Bitbucket and Slack. We have Bitbucket Slack bots, which let us know when there's failing builds or when there's pending pull requests that people need to review.
And now talking about our methodology, we had a bunch of great tools that we use, and we implement a Scrum methodology, but during our research, we wanted to add one part of feature-driven development, which was the initial modeling. We found this useful for us because we had an existing system, we had our project domain well-defined, and the feature set was already laid out for us. So we grouped our features by user persona. We wrote up documents for each user persona, and that gave us our framework for our full year plan going forward. And it defined all of our epics that we were going to work on. We started off with 1 week sprints, and we found that was good for sprint zero activities, researching frameworks, technologies, and just getting the team up to speed. We chose 1 week sprints because we were meeting with project sponsor once a week, we were meeting with our project coach once a week. Just made sense for status updates and all of that. However, we had a retro and we decided during development 1 week sprints just wasn't long enough, so we made the switch to 2 week sprints. And we have our sprint schedule up here. We do all of the Scrum ceremonies, we do project pointing, or we do story pointing, we have our backlog, and from our backlog we pull stories into our sprint, and we commit to those for our 2 week sprint. For the metrics we track, we have our timesheet where we track our hours, but we don't only track our hours, but we track what those hours were spent on. We have a variety of categories. Our two biggest ones are development time and process time. We have a lot of process meetings, that's why that's so high, but there's a lot of value out of that. We also have our burn-up chart and sprint velocity. Those are collected for us through our Atlassian suite and our Jira boards, using our story point estimates and our poker planning for user stories. We can estimate how much work we can get done in our 2 week span, and we can plan not only our 2 week sprint, but then using all of that data, we expand out through our epic planning, and we can estimate how long each epic is going to take. And we have our full year plan off of that. We also have a DRE chart to track defects. A lot of our defects come from the requirements phase and design phase, because we have our initial feature set design that we started at the beginning of the year, and then we're going through and we're reevaluating all of the requirements, we're reevaluating the design of the current project, and we're making a lot of changes to those. And we use Jira for our epic length schedule. This is our current schedule and all of the epics that we have. I'll pass it over now to Ryan. Talk about requirements.
So, a large majority of our requirements were gathered during Sprint 0. Each week, our sponsor would give us a demo on a different user role, and we would use that to generate an FDD feature set containing all that role's features. We would then take that FDD feature set and turn it into a large amount of user stories, which we would group into our epics. Now, because this was still early in the project lifecycle, we had a relatively poor understanding of the requirements as a whole, and so this fed into a cycle where we would generate and improve our design based on our knowledge of the requirements, and then we would use the feedback that we get from demoing that design to our sponsor to improve our knowledge of the requirements. The existing athletic architecture design actually was very rigid. To add a new sport, as mentioned before, you would need to add a whole new database table. That's the opposite of extensibility, which is one of our main project focuses. So, as a result, our project focuses on generic data objects, where you can add a new sport, you can add a new league, you can even add a new kind of stat, all without needing to actually edit the code or change the database structure. Now, while this is certainly extensible, it does have its trade-offs. Implementing this took a lot longer than it would have taken to implement a simple, rigid design. And in the future, if you're adding a truly custom feature to something else, you still need to make code changes. That's not something that the generic data objects can really handle. We use JUnit for backend testing, which involves both mock API calls and testing the business logic on the service layer. We originally were going to do automated JavaScript testing using Jest. However, once we truly understood the very large scope of the project, we decided that the time cost would not be worth the benefit, and that we would only do manual JavaScript testing during pull requests. Next semester, we plan on doing extensive user testing, bringing in real-world users of the current athletic system to make sure that we are building the product that they need and that we are building it right.
So, one of the most important steps at the start of any new project and product is dealing with what features exist. It's deciding how they exist, how users are going to interact with them, and how we as developers are going to arrange them on the screen for users to interact with. So to begin this process, we started with the whiteboard, as most people would, and tried to get a vision for what this product should feel like. We started with fans, teams, and team groups, some of the basic features that the system has. And these are just the very first iterations of our designs, and we use them as a starting point for the entire design process. So next, we move on to higher fidelity whiteboards, deciding things like what do game reports look like, what does the top bar feel like, and what icons are we going to use for navigation, things like that. When we look at that and build an initial wireframe, we wanted to build something that would be relatively generic, but just an initial process. So we built a wireframe using a tool called Envision to solidify some of the design choices that we wanted. The design will evolve over time as we move forward and add new features to the system, but it's important to have an idea for what the product will look and feel like. When we began to start implementing, we began to realize that we really are going to need to build out a lot of features in a short amount of time. What that meant for us is that we decided to use a UI library that would help us move more rapidly and not waste a lot of time tweaking CSS. So we chose something called Semantic UI React, which is a really wonderful library with a lot of pre-built components, such as cards, forms, and icons, really stuff we didn't want to waste time building ourselves. As you can see, using Semantic, we were really able to build out some of our use cases in a short amount of time. This graphic is showing the user flowing from team groups such as NFL to team pages like the Eagles with a responsive and clean UI experience. And note that this is just not data that would actually be in the system.
So, now we'll be talking about some of the risks, concerns, and challenges that we faced in this project, as well as how we've been tackling them. Our largest risk, as some of you may have surmised by now, is that this project has a very extensive scope. We're rebuilding a project that is quite old, and more than rebuilding it, we're supposed to improve on it and make it better. This means that we need to prioritize which features to deliver first in order to ensure that our sponsor receives maximum value from the work that we've produced here. We need to make sure that we aren't missing any important requirements by regularly communicating with the sponsor and the coach to ensure that everyone on the team is on the same page as far as what is being delivered and how it is being delivered. We also need to keep ourselves focused. With a large amount of work, it can be difficult to avoid getting bogged down in one feature or doing things like gold plating or allowing scope to creep beyond its original limits. We need to ensure that we're keeping ourselves focused so that we avoid those problems and we deliver the features that we're meant to deliver. And in order to ensure that we deliver the features that we're supposed to, we have committed to an aggressive schedule to maintain team productivity. However, this means that we need to be careful about potential slippage. Any slippage is quite dangerous, as slipping behind on an aggressive schedule could lead to even more difficulties further ahead, which we have mitigated by ensuring that we are prioritizing the most important work to be done first. Lastly, the final risk that we've encountered is that the system, both in its current existent form and the form that we're building, is complex. The original system served many types of sports, such as soccer and hockey, and a few other ones like basketball. Each of these sports have individual rules and laws that must be followed when the system is built. We're supposed to rebuild the system in order to deliver the same value to the current customers, which means that in rebuilding the system, we must keep all of those rules in consideration as we're building out this generic, dynamic version of Athletic. This means that we have to be very careful about potential exceptions to the rules and that we need to also maintain the original functionality. So, to give a quick status update about where the project is thus far, currently we've implemented sports, leagues, and teams into the system, as well as seasons and subscriptions. As it is right now in the system, you can create any sport, may it be soccer or archery or any sport of that kind, and you can create leagues for that sport as well as teams for that league. This means that currently we have the bare bones of a league management system, although up ahead we plan on implementing competition, statistics, tournaments, and organizations to further flesh out the system. In the future, we also must keep in mind the user acceptance testing that we have planned further ahead to ensure that we're delivering the product that the users want and that we're successfully building the right product and that we're building the product the right way. And last but not least, there's also considerations of the handoff process. This project is intended to live long after we're gone, and so we need to ensure that Sean, our sponsor, or whoever else will be working on this in the future, has the proper amount of domain knowledge required to continue working on this project long after we're gone, without needing to constantly refer back to resources that may or may not be there. And with that, we'll go to questions.
When you guys were introducing your team members, you guys had what appeared to be roles below your name. And so one of the things that I noticed was you have someone listed as a team coordinator, and then someone else listed as the scrum master and the product owner. It seems like a lot of management on a senior project team, especially one with 4 members. So I was wondering how that dynamic was working within your team.
So we do all develop. We're all developers here. We're all engineers as well. But it's important that we have somebody who is a scrum master, and important that we have somebody who's our team coordinator. We just have so the other individuals, myself and Ryan, took on other lead engineering roles to solidify vision in those areas, but not to actually do all the work in those areas. We divide up the work as needed.
Right. And to build on to Dan's answer here, I would say that the reason why we chose to split up the roles that way is to ensure that somebody takes ownership of what needs to be done. Someone needs to make sure that the team meetings are being scheduled and that everybody will be there and which team meetings need to be had, which is the role I took. Brian is the one who takes care of our backlog, ensuring that features are prioritized as they need to be, and ensuring that we have the right features in the backlog and that the user stories are what they should be. And those really are two different things if you think about it, as I'm sure you know. But that's kind of the thought process we had in going about that.
Sorry to ask about the whole thing, but I thought it was really interesting you guys also had a security engineer, but I didn't really hear too much about it in the presentation. Can you talk about some of the security choices and designs that you did?
So, looking at the original Athletic design, we noticed lots of opportunities for better security, and especially with how the user roles change from the original design to our design, there are lots of opportunities where, if we're not careful, we could have vulnerabilities.
So, and to build onto that a little bit more, we've implemented Spring Security, which is the suite that they offer to secure your endpoints and your web pages. Although there's a different security. I'm not the security guy, so I can't tell you in great detail. And without going too much into detail, it is something that we've paid heavy consideration for moving forward, because in this day and age, you have to be very careful about how you choose to go about developing your web app so that you don't expose yourself to future vulnerabilities in the future. So.
It seems like you guys have a really well thought out yet involved process. Do you find that it really slowed down your development time? Looking back, would you change it for a more lightweight one, or are you happy with how it contributed to your process?
We're happy with how it works. We have everything laid out. This seems like a lot, but we just, with a couple meetings, we know exactly what we're committing to within our 2 weeks, and we have our plan for everyone to now go forward and do their work.
I think it's Brett mentioning Dan is the reason you have a lot of that process.
That's not very nice.
No.
It was a team effort, I think. Each of us wanted a little bit of it, and then a little bit added up to what we have currently. While it is a good amount of process, a lot of it we find to be critical, because a lot of these stories we essentially need to convert from the original use case in the old athletic system to the new use case in our new athletic system. And then we also need to consider areas for improvement as we're building out the new system. So a lot of the process is required to ensure that we get the best design, and it's not just one guy pushing ahead with, this is the design we're going with, and then further down the line we have to do some refactoring in order to not fix, but to update their design to what the team vision has the design being.
And also, our metrics slide, which we showed a little bit ago, shows that we are doing a lot more development than we are process work. So while we do have a good number of hours into process every week, we are also putting a lot more hours into development, which is really the meat of the project.
And in addition, that graph is slightly misleading, because for the sprint zero at the beginning, which was a series of sprint zeros, we did not have any development going on, and so process was the majority of the time spent there getting the project off the ground.
Right.
Once we got actually into development, we ended up with a much larger development chunk of time being used.
Let's thank the team.
Ready? Okay. All right. Hello, everybody. We are Team Ponds. I'm Mackenzie Bowe, and then I have my teammates Nathan, Sadaf, Colin, and William. Our sponsor, unfortunately, couldn't make it, but his name is Travis Dessel. Our sponsor is JP Morgan, and our project is the cross-blockchain trading bridge. Before we dive into what all that means, here's a little bit of an outline. We're going to start out with an introduction, talk about our problem statement, our solution, a little bit of our challenges. Moving forward, we'll talk about the design process, a little bit about our testing, and then finish up with a roadmap and a summary.
So before we get started, we want to clarify a few terms. This is kind of a big project, and it's a little bit hard to understand. A blockchain is like a mutually distrustful network, something that it runs on like cryptocurrencies like Bitcoin, Ethereum. Specifically, Quorum is a fork of Ethereum used for private transactions across like an institution or a organization. Ethereum is a fork of Bitcoin, which eventually allows for smart contracts to be developed on it. Basically, just coded functionality within the Ethereum network. The cross-chain bridge is sort of bridging between two different blockchains. So if we have one blockchain over here, one blockchain over here, how do we do a transaction that goes across those blockchains without using like a traditional exchange for like monetary funds? Web3j is a Java Web3 injector. That's something that we're going to be using in order to use this bridge. And smart contract escrows. An escrow is sort of a place where you put money so two parties can sort of agree that, reach an agreement about something. So say like you had, a Boolean basically that says, this person agrees to this trade, this person agrees to this trade, and then the escrow actually will release the funds. Current blockchains do not actually have a uniform solution for exchanging tokens across blockchains. This is kind of the big problem that JP Morgan approached us with and basically said, we have an ERC20 monetary token, so something that represents cash and a loan, and we want to be able to exchange, an instance of a loan with a certain amount of monetary tokens across two different blockchains. And they're using the Quorum blockchains because JP Morgan developed Quorum just for internal private transactions, that sort of thing. Yep, we'll be utilizing Web3j to take care of this problem. That's just through a Java instance that will have a server running so that people can access it through a web browser. This makes it both mobile device and desktop compatible. And we're going to be using just our team developed ERC20 and ERC721 tokens. This is not something that, in the future we hope to be able to do reusability with this so that multiple types of ERC20 and ERC721 tokens could be utilized. But for now, we're just focusing on getting the basic functionality working.
All right, so now our solution. So now one of the hardest parts about a blockchain is kind of talking about it. How do you tell someone with limited domain knowledge what we're doing? So we kind of have a quick kind of skit to represent different assets we've created and how they talk to each other, okay? So our problem is we have Colin. Colin over here, he's fresh out of college, has a bit of money, and he wants to buy a house, okay? We have Mackenzie. Mackenzie has a house and he's willing to sell it, okay? So we have Colin over here, his ERC20 is monetary token, and then we have Mackenzie, he has his ERC721, kind of your loan token, okay? They want to swap with each other, except they are on different networks. So how do you do that, okay? We use a solution which uses escrow contracts, which are going to be represented by Sadaf and William. These are programs that are run on the blockchain, which you can give certain tasks, such as trading money, and they will accomplish that. Okay. So now, to initialize this swap, Colin, our initial person, he'll log on to our site, and he has to fill out some certain features, which will then become our escrows. So this includes the ERC20 address, which is Mackenzie's address, his own address, as well as the amount that they've predetermined are going to be swapped. So we're going to give 500 of Colin's dollars. This has become the one house that he's going to buy. Okay. There's also a time limit and then a passcode, which we'll get into later. These are how this transactions are done securely. So once Colin has officially entered all this information, the bridge will go ahead and it will create the two escrows. Okay, we need one escrow for our ERC20, our monetary network, and then another one for our loan network. Okay, so we have one escrow here, one escrow here. Both on separate networks, they can no longer talk to each other. Their only point of contact is the bridge. So now, Colin's gone through our system. He's created these escrow contracts. Now we need Mackenzie to go into our system to review these contracts to make sure that whatever Colin put in is valid. Okay, you don't want to like go into your. You don't want to give your assets to the escrow before you believe that these contracts are accurate. Okay, so this is just kind of a review. Mackenzie's going to log in. He's going to put in our two contracts, and then he's just going to be given a simple
simple explanation of this is what's going to happen when you insert your assets. Okay. So they both agree. They both reviewed. All the escrows look good. Okay. Now they give their assets to the escrow contracts. So from this point on, they have lost control of their asset and have given them to the blockchain kind of controller, these escrow contracts. These are programs which will validate that the transaction have happened before giving them to the other party. So now we have to have our transaction complete. We have to say Colin has given his money to the escrow and Mackenzie has given his money to his escrow. Okay. To do this, they go into the system again, they type in their escrow address, and then they put in that password that was predetermined. That password will unlock the funds for the other party. And then once these are both done, an atomic swap will be able to happen. Okay? They both have to do this before that transaction can flip, before the two escrows will unlock their funds. If both transactions, or they've unlocked their funds before the timeout, which was in the first kind of initial step, then each escrow contract will release its funds to the other party. So we'll have William, the one escrow, will release his funds to Colin, and vice versa. Okay. So now at the end of the day, we have Colin got his house, Mackenzie got his money. Okay. If the timeout happened, which means one of the parties they ran out of time, they were indecisive, or something happened, then the escrows will simply return their assets that they own to the original owner.
So for this problem, we come up with the total design of our application. So our application has three main components. The first component is the front-end application, which holds on our asset account. This will provide a UI interaction for the user client on both networks to kind of fill out the application and interact with each other. And we have the second component is the bridge. The bridge will be the main thing in this whole project to perform the swapping, privacy checking, and validation, or any kind of locking mechanism between two different networks. And the last component is actually two different blockchains on the core network. Those two blockchains supposed to exist in two different networks. But at the moment, we just put them onto one VM machine because we don't have more resource at the moment. And for the design, during the design process, we came up with a lot of different ways to solve the problem. And there are two big decisions that we make by the end up until now. Was one, we had to come up with a way to prevent kind of false transaction when we perform the swap between the bridge. So for example, if one user kind of agree to make the transaction, but then later on he kind of change his mind, how do we prevent the case where when one transaction go through, but another one not go through? And it's kind of create problem. Another thing we have to make a big consideration is the privacy of the user, because when you deal with blockchain on two different networks, it can create a lot of issue with how much information does each user has to give the bridge to perform the transaction. So we need to figure out a way to preserve the privacy of the user wallet even after the transaction.
So as William just touched on, and also from our demonstration, there's a lot of considerations and a lot of new technologies that we have to work with. So we had to put a lot of time into our process thoughts. What type of methodology would help us best? So we decided to go with the spiral model. Four main components. There's just determining objectives, identifying and resolving risks, developing and testing, and then planning the next iteration. So this model really helped us really help us set out our objectives early. A lot of different factors listed up there as well. It's a risk-driven model here with blockchains and the privacy security issues that we already mentioned. There's a lot of risks that we need to touch on. It's iterative, of course, so we can get a prototype out early to our stakeholders, get feedback often. We talked a lot about our design prototypes already, the different considerations we had to make. So that was really easy to get our thoughts out there to the stakeholders and see what they think. Moving forward, this is a little overview of what we've performed so far. So we're looking so far 4 cycles per semester. We started with the initial setup, working, getting the VM set up, then setting up the actual blockchains, of course, and then we created our back-end application, and then an entire cycle was based around that thing that Nathan mentioned earlier, the atomic swap. And that's crucial to making sure that funds are transferred at the same time. You don't want to have people run away with other people's money. And then, of course, we also have a metrics plan in place. For our project plan, right off the bat, the sponsors at JP Morgan gave us a proposal saying that scalability and performance is definitely important. So we're looking to set out time the transactions, because we can't have people waiting forever to get their house or get their money. And also percent of failures, because we want to monitor and make sure everything is running smoothly. And then there's the 4 process steps that I already mentioned that we would go through for each of those cycles listed on the left side. Moving forward, this is a little bit about that risk step more in depth. Below there's an example in cycle 1. So as I mentioned, we had to set up Quorum, get that running on the VM. So one of those big questions is how can we get that running on the blockchain and how can we test it? We analyzed it, we saw that that was a very big risk, something that we really needed to tackle because it's crucial for the rest of the semester and the rest of the project. So mitigation, we were working a lot together as a team, brainstorming on whiteboards, reading through papers, what's the best way we could get it done. So that's just one example of our risk analysis. And moving forward, this is just another thing we use for the process. Trello kind of incorporates that Kanban methodology that other teams have already mentioned, but we've used it basically to visualize our spiral cycles, because spiral is a model, but it was also important to have a central tracking location that we can just see what everyone's working on and organize into different cycles. And everyone's familiar with it. I think like we start its second year in school here working with Trello. It's a very useful tool.
So as a team, we came through a bunch of challenges that came through our way. The first was getting a VM from the IT department. Initially, we had some challenges just getting a VM due to how long it took, as they're also as the IT department's also provisioning VMs for other teams, as well as having a bunch of other students. And then once we finally did get a VM, unfortunately, it lacked virtualization in the BIOS, which stopped us from putting VirtualBox on the VM. And we needed that in order to put our Quorum instances on the VM. So after that, we settled with a Linux VM. So as Colin mentioned before, we do have like a lack of experience in the domain. Most of us have never worked with blockchain, so a lot of the semester has been used researching. We read up papers on blockchain, Ethereum, looked up existing implementations of current tokens, ERC20 tokens, ERC721 tokens. So that, and as we mentioned before, Ethereum is a major platform of blockchain, but Quorum is more so JP Morgan's fork of that. It's their implementation. So because of that, there's not a lot of valuable resources online for us to research and things of that nature. And then I'll be going into the testing challenges we had with our distributed systems. This included our Quorum instances and the bridge as well. So at this stage, while we've completed the swap in the console, it takes us to manually go in and start the transaction ourselves. So obviously unit test wouldn't work since our system isn't fully built, so anything automated of that nature wouldn't be as feasible. And then as well as the different times it takes for a transaction to finish. Let's say Colin started a transaction and his finished like in 30 seconds, but let's say Williams finished in like 45. There's a lot of issues with testing that. And so we also want to ensure that once everyone, let's say they time out or someone cancels the transaction, that each party is able to get their tokens back. So some additional testing challenges we faced is that when someone starts a transaction, we don't want to prevent them from others starting their own transaction or finishing, as well as when a transaction does finish, on the blockchain, everyone's blocks gets updated, and that it says who they interacted with, how much they spend, what did they receive, stuff like that. And then obviously the main thing we want to ensure is that both parties get their coins at the end. So our testing plan for the future, the main purpose of this project is that we want to ensure that the transaction takes place successfully and everybody gets their coins in the end. For integration testing, we found a library that's provided by Quorum. It's called Quorum Tools, and it's good for integration testing on the Quorum network. So that includes our bridge, our 2 Quorum instances. And then as we've been developing smart contracts, we found that Ethereum has sort of an IDE for Solidity. Solidity is what we use to write our tokens in. And these have test nets where they manually test the coins of if you can send them or receive them. So.
Cool. So here's our roadmap. As was mentioned before, we did spend a lot of time this semester actually learning about blockchain and Quorum specifically. It was a huge undertaking. We had to read a lot, do a lot of individual research, so that really took up the majority of this semester in terms of time. We spent a good amount of time doing requirements elicitation, as everybody does. We developed our Alpha smart contracts, modified the Quorum blockchain from the 7-node Quorum blockchain to the 3-node Quorum blockchain, so we can have 2 of them running. We did manage to get our bridge set up, so it works in the console. We got it, doing these swaps. It was not an easy task, to be honest, but we did manage to get it to work. And we did have a few implementation changes. So as was mentioned earlier, privacy is something that's very important. And we don't want, originally we had planned on having users use their private keys on our platform to unlock their wallets and then send that way. But we didn't want people to have to give up all of their funds or basically give us control of their entire wallets for a simple swap to take place. So that's kind of why we decided to go with the escrow contracts. We felt that it was better for everybody involved. Moving forward, so this locking mechanism that was been briefly mentioned with the timeouts and the passwords and stuff, that's something that we're still finalizing. It does work to a certain degree, but we really want to make it solid so that these atomic swaps, when they go through, nobody can take advantage of this system. Obviously, if there's any situation where an individual could, use our platform to take advantage of another person, people are going to jump at that, especially if it's ever released as an actual product. We do intend to finish our front end, which has been started. We had some issues with that as well in the beginning, basically just deciding what library to use, deciding which API to use. So that's kind of been an issue that we plan on fixing for next semester. And yeah, we want to make sure our smart contracts are as secure as possible. The top right is just a screenshot of the Geth console that's running our Quorum nodes. And just kind of in summary here, I want to reiterate some things. We were very heavily focused on research this semester. We really had to learn this technology. It was very difficult to wrap our heads around. We got our basic swap functionality, had a lot of implementation changes. We got our back end ready to use, which is great. So now we can really move forward here and making an actual go-to-market, actual product. We do have our Web3j working through Quorum nodes, and we got our initial ERC20 and ERC721 contracts completed. Any questions?
How exactly are you going about ensuring that your application isn't giving third-party risk the whole transaction and allowing the people connecting to it to verify that it will mathematically be certain to happen?
Right. So in our examples, in our little skit that we had, we did have a lot of steps where each user would have to review information. That's kind of important because we want people to be able to release funds when they see that somebody else has sent their funds. So that both are kind of sitting in escrow at the same time. We also have some ideas for the locking mechanism that I mentioned is going to be more developed in semester 2, which will include making sure transactions we're on the current block of each blockchain, if that makes sense. So we're at the most recent transaction area that the time that we gave hasn't timed out the exchange process, that sort of thing.
I was asking more like, how can others go in and verify that your code is going to do what it says it does before they actually go in and do the transaction?
So you're asking how when they initiate the swap, how it goes, how they can ensure that works?
How can they ensure that if they actually put money into this, if they actually do this, that your program is going to do what it says it does rather than something else?
Sure. So the main thing that does these transactions are the escrow, right? So I'm assuming you're referring to the escrow contracts, correct?
Yes.
Sure.
A little bit.
Sure. So the escrow contracts are publicly available. They're available to look at, and that's still secure. So what our program does is we use a standard escrow contract which we've developed, and then we send in all your inputs, such as the two addresses, the amounts that's being swapped for both parties. Okay, that's all publicly available. After that, there's an ABI, which, getting kind of technical, you can go in and you can physically see what's in that contract on the blockchain through an ABI, and then through that you can verify that the code is correct, as well as the amount that our application is showing is what is on the blockchain.
So I know there's a lot of risk to like defects in a software that like affects financials. Does your sponsor like offered to have someone audit this at like the end of your project to like check for defects or anything like that?
It's very much still like an experimental project, very exploratory. So they haven't reached out with that, but I'm sure moving forward, maybe next semester, that's something to consider.
This swapping process is something that really hasn't been developed on, modern, like regular blockchains, let alone the Quorum blockchain either. So it's kind of new, bleeding edge stuff. If that makes
And
sense.
also want to answer your question. Actually, last time we reviewed with one of the sponsor manager, he actually gonna touch with us beginning of next semester a list of on the list that we can come up with our implementation, so he can consider from his point of view if any other additional risk to the transaction he can see based on our current implementation. So.
Do you like people further customize specific details of the transaction or like verify like this and this needs to occur for this transaction to be approved?
So our current scope only includes ERC20 and ERC721 tokens. I think JP Morgan actually wanted to keep it simple so that we could actually get this functionality working. Like we said, it hasn't really been done frequently within traditional blockchains anyway. So we're just kind of limiting our scope right now to just our developed ERC20 and ERC721 tokens. Yeah, so they'll put in an ID. So an ERC721 is sort of like a loan that has unique IDs. So they'll be able to put in the unique ID that they're expecting to get and the unique ID that they're sending, along with the amount of the ERC20 tokens that they choose to send. And then those will all be verified through our smart contract escrows to release the funds when necessary.
That's 10:15.
Hello, we are the top team. I'm Melissa.
I'm Laura.
I'm Sultan.
And today we're going to tell you about our TOPS product locator. So we are going to go over our product statement and domain, the methodology we chose and the requirements we elicited, and the design and implementation of our product and how we tested it, and how we measured our success this semester, and how we reflected and going forward going to do better. So, this is our problem. Who here has been shopping in a TOPS grocery store and can't find the product they are looking for? It's frustrating, isn't it? You can't find it. You spend precious shopping minutes just going through the aisles, looking up and down. It's awful, and I feel like we should be able to solve this. Well, TOPS realized this was a huge issue with their customer base, so they decided that they wanted us to change their planograms to aisle numbers for easy-to-use customers. So we created a web application that is mobile-friendly for customers to search products and find the aisle numbers. This is really big for TOPS, and we're using their database to somehow simulate how users can find products. And this is really important for their new motives of becoming more technology savvy as a company. And now we're going to talk about our methodology and requirements.
So if there's one thing that our sponsor made very clear to us from the beginning is that they want this basic functionality as fast as possible. So because of that, we decided to have an iterative approach where this semester our goal would be to get the minimum features in by the end. And another reason we chose to just do one iteration for the first semester was because we all kind of had to adjust to working together, and we had to familiar ourselves with the domain and the stack, and we all had the same documentation as the rest of you guys. We actually did a pretty strong focus on trying to have a well-documented test plan and quality attributes and a lot of other things. So we kind of picked one iteration for this time and then 2 iterations for the next semester because we've hit the ground. We are now running. We've gotten there. And we want to try to, refine and process our product based on what the sponsor has given us feedback-wise, and to expand the features that we've, elicited, and to move forward with the requirements.
Right. So for the domain model, we have the customer here, which is the main focus of our application. The customer is at a TOPS location. They're looking for a product, either using a brand name or a product name or even a product category. So the product in the TOPS location store is in a specific aisle, so which is also in the store. So it all goes back together, tying everything going back to the customer.
Okay, so for requirements elicitation, again, we use an iterative process. Pretty much what we did is we went to the stakeholder and we asked them, hey, does this look good? They gave us feedback, and we just rinsed and repeated until we figured out exactly what we needed. We had a few issues with requirements elicitation, though. Specifically, we had a couple instances where just because we had a remote sponsor and they weren't in office to kind of talk to us or show stuff on a whiteboard or whatever, we had some miscommunication. One of them was the standalone versus integrated app. At one point, we had been told that we needed both a standalone mobile app and allow it to integrate into the TOPS mobile app, and so that ended up being an engineering challenge that the team can't tackle in 2 semesters, so we kind of had to back off there. So that was one thing. The desired functionality in the initial prototype, because of some funkiness with the database and the formatting, the search bar for the product was going to be most of the work for the project. And so the big issue we ran into there was that the initial functionality for the first release wasn't clarified, so we had to go and do that. And then the location response, so one of the things there is when the user searches for a product with the app, we weren't exactly sure if TOPS wanted us to send them the planogram, map of the store, something like that. Where is that data? What do we need to do with it? So we had a long conversation about exactly what we needed to give the user, especially in the initial release, to make sure that we were meeting their standards.
So I'm just going to go a little more into detail about our first iteration. We did achieve and complete all of these tasks, so I think we scoped ourselves pretty well for this semester. We had, like I said before, plans, designs, documentation. You guys know it. You had to do it. We did the same thing. Another big goal for us was a basic functional UI that followed the TOPS branding
that worked for most modern browsers, and it was mobile friendly because a lot of people in the grocery store, aka all people, are using their phones. And then for actual functionality, we wanted to make sure that we had the proper aisle returning with an exact search, so chicken noodle soup would show you the right aisle, and a similar search. Because sometimes when users type in chicken, they might mean chicken stuffing, they might need chicken soup, they might need roasted chicken, so we wanted another like broad search that would actually show the user maybe like their 10 top most similar products in those aisle locations.
So when we were gathering requirements, we noticed that the sponsor focused a lot on quality attributes. So we got some of the ones that they really focused on, and we felt that were really important for them. And we're going to talk about some of them today. So for security, we felt like we dealt enough with the security quality attribute in our application by sanitizing the input, which should prevent any attacks such as SQL injections. And we also have reliability, which ensures that our application is actually returning the correct aisle name for the product that it's mentioning. We also have availability and extensibility, which are super important as well, especially extensibility, because at the end, whenever we're done with this project, we're eventually going to hand it off to TOPS, which will integrate it with the existing technology that they have. We also have performance. We set a benchmark for 4 seconds max server response time whenever a request is made.
So now we're going to get into the design of our product.
Okay, so architecture-wise, simple model view template. We have a database, we have routes. There isn't really a whole lot to it. Pretty much everything just interacts as stated on the diagram.
For the UI design of this product, after talking with our sponsor, we realized this was not a big focus for our first iteration. So these are just mock-ups I drew myself to explain to the sponsor what we were imagining the application to look at. But we really wanted to focus on get it working with the data that they had. And it really wasn't a good use of our time to do a mocking tool. We also realized we couldn't really find many UI libraries that went in with the TOPS branding, so we realized we had to do a lot of that ourselves.
So because of our domain, there's a couple, I guess, specific type challenges that we really had to consider, and we will have to continue to consider for the rest of our iterations. Firstly is the search bar design itself. It kind of seems intuitive at first, it's a search bar, it should be easy, right? But the problem is there's categories, there's names, and there's brands. Category, for example, with Campbell's would be just canned soup. Name is tomato soup, and brand is Campbell's. Sometimes users are searching for a specific brand, sometimes it's for a name, and it's not always naturally intuitive when that input is sent back about what category that is. The second really big challenge that we had is that name badging and abbreviation. TOPS was generous enough to give us the data from their database, but that's very abbreviation heavy. For example, the Slim Fast Cream 4-pack, that's not really readable to a user. They know that it's maybe a protein thing with Slim Fast, but they don't know what all those other middle things are. So at some point, we have to take these abbreviations and convert them to something that is user-friendly and that they can actually understand that what they're getting is what they were trying to search for. And the other, probably the biggest challenge we've had in the first iteration has to do with the database. We don't really have access to their database itself. We don't have an endpoint. We don't have their source code. We had to build this database locally. They use an Oracle database that we weren't able to get a copy of. Now, Oracle is kind of built on MySQL, but it's not that easy to switch between the two all the time. Oracle has a lot of expanded features that MySQL doesn't naturally support, and there's other data types and other things that we had to manually convert their data to make it work locally for us, but in a way that would still be compatible if they tried to integrate it again in the future. These data files that they gave us are also very large, which makes sense because they're a grocery store that's been around for a long time. So, for example, the product data I think was like 15 gigs, and then the store data itself is like 24 gigs. So even just navigating these files and changing them to a way that works for us and a way that we can implement has been pretty difficult, even just trying to pass them between us so we can build our own local copies. It's been a challenge we didn't necessarily anticipate until we looked at the data around like week 6 or so.
So now we're going to get into how we implemented this. We used a very simplistic tech stack. We used Python 3 because all of us on the team have had experience with it. And when working with the sponsor, they wanted something kind of common that would be used at that other developers could pick up. So they wanted something like Java, Python. So we picked Python because we personally all liked it better. We're using the Flask framework because it's very lightweight and we think it'd be very easy for anyone to pick up and read it. We're not very UI heavy, so we have basic HTML, CSS, and JavaScript. And as Laura mentioned, we're using a MySQL database.
So as for the development process, just a lot like other teams, we are using GitHub and we're using feature branches. So we have the main product in the master branch. Whenever one of us is working on a feature, a new feature, or an improvement of a feature, or fixing a bug, they would branch out, do their feature, implement it, test it, make sure it works, especially with the existing code, and then merge it back to master. We also switched from, we also track our issues and bugs and future tasks as well in GitHub issues with specialized tags as well. It makes it a lot easier for us because it puts everything in one place, so GitHub becomes like a one-stop shop for all of us. And as for hosting, because we already had our release 1, so we already have something hosted on the web right now, we decided to go with Heroku mainly because it's free, has really low overhead, it's kind of nice to work with, and it works really, really well with GitHub. Although we encountered some issues along the way, we did not always know that we were going to go with Heroku for hosting. We always thought that we're just going to take one of the VMs that the SE department provides. So our project structure was not really compatible with the project structure that Heroku expects. That took us a while to figure out. So once we figured that out, we were able to actually get it working. We also, as easy as Heroku is to work with, we are not experts in that area. So it took us a while to pick it up and learn it in order to get it working. We are working right now on making another copy of the database that has mock data to put it on Heroku, because for security reasons, we decided not to put the actual database that TOPS provided us with on Heroku just yet.
So now we're going to get into the QA of our project.
So for testing, we have, I believe, 6 different types of testing. First and most importantly is the unit testing. Right now we have around 80% coverage. We plan and we have our benchmark around 90, so we're still working on that a little bit. Some of the code that we have on the server side especially is kind of hard to unit test just because it works kind of closely with some other things, so that's one thing we are working on. We have integration testing. We didn't do a lot of that just yet. That is mostly planned for iterations 2 and 3. We have compatibility testing just because of the sheer number of different platforms that we support. There's the common browsers such as Chrome, Firefox, and Microsoft Edge and Safari, and the 2 big mobile platforms, Android and iOS. So as for performance testing, we are going to be really heavily focusing on, especially on future iterations, on the time that it takes the server to respond once a surge has been made. We also have usability testing, just to ensure that the UI is intuitive and easy enough for an average user to pick up and use, especially on the fly when they're in a grocery store. We also have acceptance testing. We already started on that, and we plan to keep the coverage at 100%.
Okay, so in regards to risks, pretty much the biggest one that we had was just challenges in communication with a remote sponsor. We realized this kind of like a quarter way, halfway through the semester, that we were running into some problems. And so we've developed some mitigation techniques that are pretty obvious in hindsight. But so one thing we ended up doing was we keep meeting notes on the drive. The sponsor has access, we have access, we make sure that we're keeping detailed notes. We have one person who's always a note taker. We make sure that the sponsor has access to GitHub and Heroku, so everything that we're doing is visible. They can check in whenever they want and take a look. And then frequent email communication. I'm pretty sure we've been sending like an email a day or ish these last couple of weeks, and it really helps with just making sure that we're in constant contact and we have everything up to date. We also send the meeting notes to the sponsor, we send the agenda to the sponsor, and it just makes everything really nice and clear. This is kind of the heaviest bit of documentation and process that we have. This takes the most amount of that documentation time.
So now we're going to talk about how we measured our progress this semester. So for this semester, this was the breakdown of how we did our work. A lot of it was spent on documentation, which I don't think all of us were a fan of. But as Ian just mentioned, a real big risk with the remote sponsor was making sure our communication was extremely clear with them. We updated our requirements, our project plan a lot, just so we knew everyone was on the same page. At the beginning of the semester, a lot of things got lost in email chains, so we made it sure that we would make every update and make sure everyone was clear and on the same page. The next biggest chunk of the time was actually coding our application, and then smaller chunks of the time were for researching different technologies to use and designing our product. And then next semester we plan for very much the code section to take up probably like 75% of all of our task breakdown. So we decided not to go with Scrum and Agile because we thought it was a lot of overhead, so we just measured how we were doing by the hours we put in. So this wasn't super clear on to show who was doing what, but we very much made sure that we were communicating clearly, and next semester will be even more clear on what we are all doing. And now we're going to reflect on what we did.
So this is kind of our personal reflection on how we felt as a team we did. As we've mentioned a lot in the past couple slides, communication was a pretty big issue with our project, especially more towards the first half of the semester. Remote sponsors, they're challenging. Some of you guys have them. We all probably should have known that. We kind of did, but we didn't plan quite enough as much as we should have. We had the in-depth meeting notes from the beginning, but what really helped was when we started to directly send them to the sponsor right after the meeting so they could comment with any concerns that they had. And we had very clear action items that were expected from both the sponsor and from us. We probably should have been doing that from the beginning, but we did notice this about halfway through the semester, and we adapted to that and tried to change our communication style in order to kind of fix that problem. And, you know, like Ian said, we have more frequent email communication now, so most every other day we usually are kind of back and forth about something that's relevant to one of our sides. Another big change that we made that I think helped us a lot was the way that we handle issue tracking and accountability. Originally, we were using Trello, which was pretty useful when we were doing documentation and planning and just kind of trying to figure out who we were, what we were doing. But as we moved more towards the development side, GitHub was definitely a much better choice for that because we actually have features now that we're assigning to people, and it's just a natural transaction. We also modified our 4-up charts. Originally, our 4-up charts were very team-based, like what we had all completed as a team, and our risks were team-based, but we started to increase individual accountability a lot more by having our own little stand-up sections of what we did, what we needed, and what we were planning to do. And that helped a lot with our own individual accountability, especially as we moved into the development side. So for next semester, our main focuses are to actually fulfill those quality attributes that Sultan was talking about earlier. A big problem for us right now is server response times. They are a little bit slow, especially for the broad search, just because there's just like the sheer number of products in the database. We need to refine the database design because now that we have this initial product, the sponsor has made it clear that they kind of want a slightly shifted database. So instead of one that's a direct copy from theirs, they want maybe fewer tables and a different design. So we're going to try to modify that to fit their needs while keeping the actual features working as they should be. We're going to work on that search bar, like we were saying before, with the category versus product versus brand. We'd like to implement spell check, pretty self-explanatory. And we would like to do a closest match search, because sometimes when you search chicken, you just want roasted chicken. You don't want chicken stuffing. Oh, and the last feature we're probably going to plan on for the next 2 iterations is a Google Maps API integration. So as you'll see in the demo, you pick the store that you're at currently. It would be a nice feature that if the user allowed it to, it would send their location up and we would find the closest top store and ask them if that's the store that they're at. And if they approve, that's the one we'll use to search products rather than a more broad search of where they give us.
So now for the demo, as Ian mentioned, we have some mitigation techniques. Doing a video instead of a live demo is one of them. So here we have, you can select your store. We divided up 2 states where tops is present currently. So you search for a word, and if you notice the results, all the results are going to have the exact same word because this is the MVP, release 1, so it's exactly the exact match. You can see the product on the left, the product name on the left, and the aisle number on the right side. So that is in the Henrietta store right here. Yeah, and then we have a button that goes back to the search again in case you wanted to do another search. Obviously, this is just the MVP. So yeah, and now we will be ready to take any questions.
So you guys are looking at evaluating the search that you're using, do you know if there's any like tools that we will look at, like Elasticsearch or other different companies that provide search?
That was definitely more of a focus for next semester because, like we said, the sponsor actually said it really only wanted an exact search. The more flexible search was something that we added in because we actually had a little bit of extra time working on this iteration. That's definitely something we're going to be looking into to do that more intelligent searching because it would be silly to do it all ourselves.
Given all the challenges with MySQL and everything, I'm curious what else you considered and why you were able to move forward with MySQL?
Because Oracle was built on it. It's like the easiest transition for them. Most of the queries are the same. There's just a couple small differences. Like Oracle has like varchar too, and MySQL is just varchar. Even the way they structure floats is different. It's like silly little things, but it's enough that when we hand it to the sponsor, it should be a pretty seamless transition for them.
I know some of the other teams talked about like roles, like sometimes everyone's development, sometimes people like specialized. I was kind of curious, how did your roles form? Like, did everyone have different jobs, or some of that?
I think we definitely did a bunch of different hats. I know Laura, Sultan, and I were developers, but we all took on different parts. Like I took on more of a front end. Laura was great working with the database, and Sultan was great working on developing and also doing testing. And I think we all interacted with the sponsor, but I think Laura and me took like more of a team lead. I don't think we really wanted a product owner for ours, but we definitely felt that we made sure to keep up on emails and do everything, but we all kind of tried to work together.
But I saw different questions.
So just working, like designing an app, mobile application, if you're sending additional complexity, you might have had if you were designing web applications?
It was definitely a little bit interesting for the UX because they wanted web, tablet, and mobile, so a lot of different applications. We tried to make it as simplistic as possible so it would look well on all of them. I think in the coming iteration we're going to focus more on the UI and UX and try to get more feedback from the sponsor of what they want to see from it and if there are any changes for the different interfaces.
Anything else?
You mentioned maybe working more on your UI and UX. Are you thinking more that you might want a dedicated layer to the front end to work on it and make it more complex there, or do you think the templates will handle your needs for the product?
I think we definitely need to talk with our sponsor more on what they expect. I think right now it's very basic and a little gaudy. We'll admit it's not the most lovely, aesthetically pleasing, but it's also very difficult to find something that matches the Topps branding because their website and mobile are very different user flows and UIs, and even inside their mobile application, it's very different. There's different button sizes, different button colors. It's not very clear, and I think this is a really big step for them, taking a technological big step forward to work with us. So I think we just can keep working with them and try to find a good solution.
Thank you.
We're good to go? We are Team Jaw. That is Jonathan, Adam, Austin, and myself, William. And we are here with our sponsor, Mr. Jim Bundy, and our coach, Dr. Newman. I want to take a moment to thank them for all their support. It's really been a rich and rewarding experience, and we're really looking forward to next semester. So with that out of the way, let's explain the name here. So we are creating a product called Presence VR. This is a second phase project, which means a team last year was developing what they called game room recruiting. That's what you guys will have on your evaluations. They took the problem statement and used it as a research task and a prototyping task in order to create just a proof of concept. Then we took that proof of concept and all their research and findings and are now developing an actual production-ready application. So the problem statement that we have here is pretty much interviews are a very costly process within the hiring process itself. For example, for interviews, there's a lot of expenses that go in onto the company side for employers. They have to send out recruiters and interviewers all across the country to multiple campuses. They need to correlate with the campuses. That's very expensive for the students. The logistics of that can be challenging, especially if you have to travel to their headquarters. That's a lot of expenses on you. In particular, I know one of the primary cases, not for you guys, instead it's for the art students. You guys are very fortunate. You have a lot of, as software engineers, we have a lot of companies that'll come out and see you or even pay to have you come out see them. Art students don't have that luxury. They'll pretty much need to show up at their own expense or they're not at all in the running. So in order to help them, we're creating an interview process that allows them to do that remotely. And most importantly, all the current solutions, so what you would call like that Skype style interview, really there's no presence of what we're defining as presence as being, in that face-to-face interaction, being able to look in each other's eyes and kind of get that real 3D interaction there. So our current solution to this that the other team found, and we are now creating a production-ready implementation of, is a web-based VR implementation that's going to alleviate all those expenses, allow you to transport, instead of physically, do a 3D representation of your artwork. Imagine an art gallery where all your artwork is kind of put up along. You can walk together with your interviewer and show them, oh, look at this painting over here. And you can see like this over here, oh, I did this with using this technique, or let's watch this video together. And you're able to get the artwork and everything you want there at that time and create that presence using that virtual reality environment. This time I'm going to go over to the requirements with Jonathan.
All right, so what would the requirements for such a project look like? Well, our very high-level requirement was we were going to take the prototype and produce a production-ready application. To the right of this slide, you can see screenshots we took of the prototype we set up from the last team, a room list, and what it looks like if you go into the room. The room list had no idea of users or permissions or anything like that. You could join whatever interview was in the list, and the interview list had every interview ever created. In the room, you can see that the VR space was set up with a 3D image, 360-degree image, and it kind of stretched out the graphics a bit. The webcam wasn't very centered, kind of cockeyed. So we sat down with the sponsor after setting up the prototype and came up with what we define as production-ready requirements. There were two sides to this. The web app requirements, which included server, client, and cross-cutting, and the web VR requirements, which included configurable environments, assets such as 3D models, images, videos. What we're defining as virtual presence, the most important part, of course, coming from the one-on-one user interaction with many-to-many as a stretch goal. So, at the start of this project, the requirements were still kind of unclear, and since this was a completely new concept, we decided, after a little bit of debating, to go with evolutionary prototyping as our methodology. This was the best methodology for our project, since we could redefine requirements as our research and development continued. We could experiment with features that we deemed would be important to our project. We could evaluate our progress really easily, and we can refocus depending on whether or not we needed to. So we had some of the standard risks, silver bullet technology, and things like that. But one of the risks we really wanted to emphasize was excessive scope. As we eventually used our mitigation strategy on this. Our scope was large from the beginning and continued to grow until it became unfeasible that we would complete everything. This eventually broke through the prevention strategy that we had, and we had to revert to our mitigation strategy, where we held an emergency meeting to redefine our focus. This mitigation strategy worked, and we came out with a streamlined feature list and a much more manageable scope. So for project tracking, we used a couple things, timesheets and 4-up charts we all used. We used the Jira board. This was inherited from the previous team. And after a little bit of research, we decided this was the best thing for us to use. It did take us some time to learn how to utilize Jira to the fullest, as you will see later for our metric tracking, but we plan on improving this for the second semester to track time spent on stories and tasks. So here's one of the metrics we got from Jira. It's the flowchart. As you can see, this is where we don't look so great. We put a lot of stories into the backlog. We put them into selected for development. There's very little stories that actually have in progress and selected for validity. And most of the stories were just put into done after the release was done. So we never really had any stories really being tracked during the release.
So the second metric that we used, which is really nice because this was automatically generated by Jira, so we weren't putting a lot of overhead into generating metrics. We were able to really use just one system to keep track of everything. So what we can see here through our control chart is on the left side, we started off with our predictability pretty wide before we started norming with our team and getting familiar with the actual domain. And as we got more familiar with the domain and we became more robust and secure in our process, we really became much more predictable. All of our, especially the bigger clusters of our user stories, which are the green dots you see here, really kind of clustered in, and it became very easy for us to just go from one release into the next one. You can see there's kind of a dip down, a increase in our overall predictability once we reached break, which we did expect, but then it continued to improve after break as we continue with our process there. The story point that kind of like you can see the outliers, those are just research tasks that we continued throughout the pretty much duration of the semester that kind of weighed in on the rest of our stories. So really everything here was optimal for us. So moving forward, what really went well, what didn't go so well? Honestly, we had a very good team. We worked great together. Even though we're coming in, the first time we met up, we asked each other, like, so who has experience with VR? All of us said none whatsoever. So we really came together. We all took the research and the process very seriously. Just with how committed we've been to our process and our bi-weekly release cycle, I think has greatly benefited us. And this has allowed us to continue to release actual features and make more progress than I think we even expected to make from the beginning of the semester. Some of the things that maybe didn't go so well, like we said, with our risk, we did end up having like an issue with scope creep, but solved it right away. There was no problem using the mitigation strategy. Risk management really does pay off. There's a big difference between CS and SE, and I think this project really demonstrates that. So from here, really, I think we're moving forward on good footing. There's a lot of unknown unknowns that we're going to keep track of going forward, but just because this is a product, it doesn't exist. Nobody's done it so far. We're really keeping track of what those risks could be. So the process plan going forward, we did have a lot of really small stories. So we made sure, like we said, using Jira, we did use story points, using that Fibonacci kind of style. We did use small points, so usually stories were like 1, maybe 3, at most 5 story points to keep everything isolated so individuals could take those tasks. And if they end up being too big, we would just split them apart because that's the correct way to do that. We kept track of everything pretty much on Jira, and that was a very useful thing to do. The previous team used Jira, so our sponsor was already integrated into that, and it just helped us move forward. And it, like I said, helped us generate our metrics without needing extra overhead, because I know a lot of times process can swamp your actual productivity. So we're going to move forward here to the design with Adam.
All right, so regarding the design of the application, we wanted to keep things simple. These are probably the crucial design decisions you can see over here. Developing over refactoring. So I know a lot of people here had inherited code. I think you could tell kind of from the glimpse it was more of a prototype situation, so it's not exactly the same kind of cost as having a fully fledged legacy system that you might need to make that kind of decision with. Obviously we chose to develop a new solution. Web-based was important because that means that eventually this project can target all VR platforms that have web access. So that's everything from as expensive as a top-end Oculus down to like the phone solutions. Another was that we will be using NoSQL. Since given the evolutionary prototyping nature of this project, it's going to be quickly iterating. We really don't want to be defining a rigid table schema that we need to update every time we decide that maybe an interview needs to track a couple more things, that kind of idea. You'll also see that we moved to an interview first design. So the last design centered around kind of like a chat room style. We decided that this is a career services project, and the primary purpose will be interviewing. So from a user experience point of view, switching to a design that's more centric around interviews made sense. You'll also see we decided to integrate Google authentication instead of RIT authentication, and this kind of came out of talks with the sponsor. We found out that integrating companies into RIT solutions before has been pretty painful. Because they won't have exactly the same accounts as students or professors, they exist kind of in limbo. So by integrating Google, we give easy access to the system. And then lastly, we did investigate AR for a bit. There's a lot of interview possibilities that jump to mind when you think of augmented reality, but what we found is that we could not make an accessible solution that cost a reasonable amount, and we could not put that expectation onto the customers that a student and a company would have to have an AR setup. Here's the domain model. There's a bit of information here, but like I said, the most important is that now the interview is kind of the center. You'll see that there's a notion of roles, who's the interviewer versus the interviewee. This kind of relates to permissions. You'll see that this is a basic representation of the interview configuration, the primary children of that being environments and assets. And then lastly, as more of a future thought, creating a role of an admin that can exist within the system for management purposes. So just like everyone else here, we did mock-ups. I don't want to go into too much detail about these. This is our home page and our interview page respectively. As the plan progressed and we decided that the VR component was more the focus of this project, we've kind of reduced some of this work on the front end. And here's our architecture diagram. So again, you don't need to read all of this. This is pretty standard server-client architecture. The outlier here is the Google Auth servers that both connect to. On the server side, you'll see we're using just MonoView controller, similar to everyone else. We do have a monolith service, so we decided that this project wasn't big enough to break into microservices. And we're using, of course, the NoSQL connection manager. And on the right side, you'll see our React application. That primarily most of the meat is in the home page and the interview page.
So going on into our implementation, the biggest thing with the implementation is that we are taking the research from the previous team, and we trusted their findings in that actual prototype, and that is a valid solution to this problem statement. So the technologies that they had chosen, especially for the back end here, using a Ubuntu server, on top of that running Node.js, MongoDB, and Express to run that back end and to serve all the routes. Up on the front end, we have React, creating components for our individual UI sections, and we're styling using semantic UI React. In order to do authentication, we're using Firebase, and then A-Frame is kind of like the big chunk of, or big difference with this stack. A-Frame allows us to do the actual virtual reality implementation inside of the interview. And what's really great about A-Frame specifically is it allows us to put that inside of the browser. So the rationale behind this, like I said, the team before us chose this stack, and we did really want to dig in and get some development done. That was the whole point of the first phase of this project. We wouldn't want to just forsake all of that by changing the stack. But the reason we agreed with their selection, because we did do our research into the stack options, React and especially MongoDB especially fit our needs, given that this is a project that there is no other implementation and it's brand new, cutting edge technology. We needed something that could adapt to the change in the requirements. So React, it's component architecture. You can change and create new components as needed. And the same thing on the back end by going with NoSQL. we don't need to redefine tables if our requirements change, as they are most likely to and have continued to. Like I said about A-Frame, you can put it right into the browser. Without the VR headset, you're able to manipulate and move around, which is an important requirement for our sponsor and our end user. But at the same time, putting the whole headset on and the overall performance is exactly comparable with what you would see with Unity or Unreal Engine. So I want to go from here into our testing with Adam.
So just so we have time to go over kind of the results at the end, I'll kind of expedite the testing system here. The API testing, this is standard stuff. You've seen this in a couple of the presentations already. We're using Postman and then a variety of JS frameworks for unit testing. These kind of help with more of the asynchronous operations that happen within the system. This is relatively uninteresting stuff. You know, your API should have clear inputs and outputs. What's been more of a challenge is the system testing. So at the moment, this is a manual effort. As you can imagine, system testing, creating automated system testing for a web app, a server, and a VR product embedded is very difficult. So we've got some standard procedures here, integration branches, PRs, and then well-defined regression criteria that we make sure before we approve any changes. That's kind of been our effort around that. And then most importantly for second semester is going to be the UX testing. So we do have, through our sponsor, companies interested in trying this platform out. We've also interested in getting a couple students on board and getting their first impressions based on the app.
So, over this past semester, we've made some significant progress towards our goal. So I'm going to show you some screenshots of what we've implemented so far. So one of the big components we've gotten done so far is our authentication as far as security. You know, you want your interviews to be private, and we made sure that only you can see your interviews that you're a part of, and made sure that not anyone can just get into the system and just view any interviews, especially since there's important assets that have to do with each interview. So we made sure that setting up an interview was pretty simple. You know, we wanted to make sure that anyone would be able to set up an interview and use this app. All you need is just the email of the interviewee that's going to be taking part, or multiple interviewees, and then just the date and time. And then from there, it'll just create an app in our system. So this is the home page we have right now. You'll notice the calendar isn't there. We decided to focus more. We figured that was something that could be put more on the back end of things while we implemented the rest of the system, especially the VR. But for right now, you can see you've got two different views between whether you're hosting and participating. If you're hosting an interview, you have the ability to edit an interview, whether it's add or remove participants or change the time and date. And then if you're a participant in the interview, you don't have those options and you'd be able to leave the interview, which in that case your name would be taken off the participants, whereas a host would be more able to delete that interview if needed. So this is our page, what the interview page would look like. As you can see, we have our VR section that we have added at the moment. Right now you can just walk around. What we're looking to add, kind of be able to add like assets and environments into the VR space. Right now you can upload any assets and environments you want, but we're working on moving those into the space. You can currently see also the progress of, who's online and who's within the interview. And then on the bottom you have our chat, which there will also be notifications that you can see as far as people entering and leaving the chat, and then any assets that are also being uploaded. Also, one more thing that's going to be added is just voice chat and any other conference things like video chat that you'll be able to switch back and forth from between the VR. So our plan for this semester, for the next semester, we're going to continue with our asset environment uploading and being able to get those into the VR space. From there, we're going to work on asset manipulation once it's inside the VR space, so moving the assets around and placing them and just being able to interact with them, especially if it's a video. Next, we'll be doing multiplayer and getting multiple people within the space, so you'd be able to get the interviewer and the interviewee both looking at the same assets within the space. And then lastly, we'd be doing the conferencing stuff, so like the voice chat, the video chat, and then also the text chat and finalizing that. And then overall, we're just going to be working on making sure you get the true virtual presence within that interview. And thank you. Any questions?
So the idea with the assets isn't actually, we will have pre-configured assets, but In an interview, those assets could be anything that the students would be showing. So we're kind of in an SE bubble here, but Mechis, for example, would upload their CAD designs, and those would 3D be represented in the space. Also maybe your resume as an image, getting that rendered in the space, that kind of thing.
Yeah. Remember when we said scope creep came up? That was exactly it. Was being able to create your own assets inside the environment came up. It was something that would be cool, but it's definitely not a necessary or like optimal portion of the features. Exactly.
And then also A-frame handles videos and just images and any 3D models that you also want to add into the that you want to render into the space.
One over here.
Right there.
First.
So obviously a VR-based project has a little bit of difficulty with actually obtaining a VR device if you don't already have one. How did you feel with that? Did any of you have a VR device, or did you have to?
Yeah. So none of us have a VR device, but we got access to the Magic Lab with VR that we can use to test.
This project's been really fun. Yes.
Yes. Yeah. So we decided that it would be best for all of our team to tackle one part together instead of dividing us up into separate areas. So we decided that this first semester we'd focus heavily on getting the web app, what we could with the web application complete, so that this next semester we could all dive into the VR and be able to help out each other.
Yeah. Because like I said in the beginning, we had no experience with VR. We wanted to spend time developing while also doing those research spikes you saw. And those research spikes were mostly into A-frame and VR, or VR versus AR. And being able to use those research spikes, we were actually able to do VR development at the end of this this semester, as opposed to just leaving all of it for next semester, which was a big component of getting our shoes wet before we jump into next semester.
Yeah, so this is a phase 2 of a project.
Yes.
And it was unclear to me, was any code or anything that the last team actually left off used here, or was it all just scratch?
We used the Express server and web config that they provided us, but other than that, we built this web app from the ground up.
And then there was some more. We did use some of the VR stuff that they already had too. And we're probably going to use some of the stuff with just some other things as far as like the web communication also. Yes.
That's what Jira is amazing for. Yeah.
Any more questions? Okay.
So the team.